here is based on Jack and the Beanstalk by Mara Alperin. You can see this is the storybook. It was chosen because it is a really engaging story for children and teachers can easily build a lesson around it. So our model animates the scene where Jack climbs up the beanstalk to get into the giant's lair, and we can see the golden goose egg up there for him to grab. The size of the model is 34 by 27.5 by 40 centimeters, which is well within the size requirements outlined in the design brief. Our model works by activating this syringe at the back of the model. Now when I push this, compressed air travels to this syringe to the one located here, and it shows Jack climbing the beanstalk. And when he's up there, you can see that his head completes a circuit and the light in the nest lights up. This completion of the circuit forces electrons from the battery inside this circuit to enter the nest and the light bulb and activate it. As you can see, the structure is robust, so it can be picked up, handled by students easily. It can be moved around by teachers from classroom to classroom, which means it is very portable. Now the materials that it is made from, so this circular platform is made from a styrofoam ring fit with 2 bits of strong pressed cardboard, and now that allowed us to make it hollow to house our electrical circuit so students don't touch it and get an electric shock. This beanstalk is made from pressed cardboard. It is extremely sturdy, and this big wide box is wide so that it can be transported and so that the structure doesn't topple over. And obviously the giant and Jack is made from plastic, and the nest and the egg is made from paper. The materials are joined, so the fundamental materials, the base, the beanstalk and the circular platform are joined with hot glue because it is the strongest adhesive that we found that could get into the hard to reach places, especially underneath here. A soldering iron was also used to connect the wires to their electrical components in the circuit housed inside this platform. Now this was to ensure that the electrical components can conduct as much electricity as possible. A mixture of hot glue, sticky tape, glue sticks and double-sided tape was also used to stick on the leaves, the rocks, the sticks and everything you see here, the paper, the grass, for aesthetic appeal. So a major challenge that we encountered was finding the materials and how we were going to build the circular top you can see here with the clouds. So after investigating lots of materials at our house, we found that a styrofoam ring fit with 2 pieces of cardboard was the perfect sturdy and lightweight solution. So it needed to be lightweight so that the structure wasn't top heavy and hollow to house our electrical circuit. This model means that teachers can use it while they read aloud Jack and the Beanstalk. While they read aloud Jack and the Beanstalk the story in a cross-curriculum approach. So that means they can merge technologies with English. It can also be used as a provocation to an electrical unit on pneumatics, as we have here, and electrical circuits, because students can actually investigate the model. They can go up and touch the light bulb, they can work this syringe here. So investigation such as this is really important, as we see here, in the processes and production skills of the technologies learning area. It also displays the engineering principles of light, circuitry, movement and forces, which is critical so that students build up their knowledge of the different technology contexts, in particular engineering principles and practices, as you can see here. So this model can really help students develop their knowledge of the design and technology learning area in particular. Thank you for listening.